In this video, we're going to show you how to use the Auto-Inlay Toolpath feature. This allows you to compensate for the tool radius when cutting parts out that you want to insert into another piece. In our example, we want to take the letter E on the left and insert it into the letter E pocket on the right-hand side. Now, because of the radius of the tool, if you're using the standard profile and pocket toolpaths, this can cause problems where you have sharp corners on either the internal or external areas, depending which one you are cutting. The Auto-Inlay Toolpath takes into account the tool radius, and so it rounds off the sharp corners, allowing you to have two shapes that will slot together without any problems. So let's go to File, Close. So let's start by creating a new file. So we're working with a single-sided job. The width is 10, the height is 6, and the material thickness that we're working with is 1/2 inch. The Z0 position, we're setting that to the material surface, and our XY datum position, we're putting that to the lower left-hand corner. And once you're happy, you could go ahead and press OK. So to help us demonstrate the Inlay Toolpath, we're going to go into the Draw Text tool. Here we're going to specify a font of Arial with a text height of 4 inches. We're just going to type in the letter E like so, close out, and we're going to take that. I'm just going to drag that over to the left hand side. With that still in transform mode, we're going to hold down Control and the Alt key, and then when I move the E across, because I've got Control held down, we're going to create a copy, and the Alt key is just going to keep that inline across when we move that over. And then when I let go, we can see that we have our second copy there. And so we want to cut the shape out on the left, and we want to create a pocket on the right for this letter to slot into. And before we go into the Auto-Inlay tool, I just want to show you the problem that we have if we just use a standard profile to cut the letter out and a standard pocketing toolpath to create the female insert. So let's switch over to the Toolpaths tab, and we'll just quickly check over our material setup. So working with a thickness of 1/2 inch, our XY datum position is in the lower left hand corner, the Z0, we're doing that off the material surface, and then we want to check over the rapid Z gaps above the material, home and start position, ensuring that everything is safe and appropriate, and when you're happy with that, you could go ahead and press OK. So we'll start by selecting the E on the left hand side where we want to cut this out. So we're going to use the profile toolpath. So with that selected, let's go into the profile toolpath. We want to cut all the way through our material, so we're going to put in Z and equals, and the software will autofill that value according to the thickness of the material that we've set within the software. Then we need to specify a tool, in which case we're going to go with a 1/4 inch end mill. We're going to machine the vectors on the outside, and then we can just give that a name. We're just going to call this one Profile Male, and then we can simply go ahead there and press Calculate, and then we can preview that toolpath and we can see the result of that there. Okay, so that's the profile. So now let's create the pocket. So we're just going to tile our windows. And then we're going to select this vector here. We're going to close out the preview toolpaths form. We're going to go into the pocket toolpath. So we're going to set our start depth at 0 and our cut depth. We're going to cut halfway into our material. So we'll put in there 1/4 inch. We're going to use a 1/4 inch tool to machine this. We're going to do this in an offset strategy, and then we can just give that a name. So we'll just call this one Pocket Female, and then simply go ahead there and then press Calculate, and then we can preview that toolpath. If we wanted to, we could give that toolpath a colour just so we can see that a little clearly. So we can see in the preview the issues that we face when we're cutting parts to fit into other parts using the standard toolpaths. So let's just zoom in on both views, and we'll just switch on the visibility of the toolpaths so we can take a look at the solid preview in the 2D view. Now, when we're cutting outside the part, we will always get radius internal corners because of the shape of the tool. And when cutting inside the part, so this pocket that we've got here, we can get sharp internal corners, but then we have radius external corners. And so we have a complete mismatch of internal and external corners when we try to slot one part into another. And if we take a look at this radius here, this would catch on the sharp corner that it's meant to match into over here. And so this just really shows the problem that we're trying to overcome when using the auto inlay tool. When we use the auto inlay tool, the software knows that we want to make one shape slot into another where it rounds off the corners based on the tool geometry that we're using. So let's just delete all of these toolpaths, and then we're just going to use this option here to fit our view to the drawing limits. We're just going to put that in C, and then we're just going to reset this preview. And so then we can close out of the preview toolpaths form. And so instead of using the standard profile and pocket toolpaths, we're going to use the inlay toolpath option. So we're going to select the left E, and we're going to go over to the Inlay Toolpath, and you can find that under Toolpath Operations. And if we click on that, that will open up the Create Inlay Toolpath form. We're going to start by looking at a straight and pocket inlay, followed by the stepped and hole options later on within this tutorial. So we're going to use the straight option. So we're creating the male inlay or the insert first. And we're just going to go for a basic straight cut option here. And so you can see that the form is very similar to the profile toolpath form. And that's because it's practically doing a very similar operation, except it's going to take into consideration the fact that we may have corners in the geometry that need rounding off. And so here we can specify our start depth, so we're going with 0. The cut depth is 1/2 inch, where we're cutting it all the way through the material. We're going to use the 1/4 inch end mill to cut this out, and it's very important that we use the same tool for both the male and the female, because the software is going to round the corners based on the radius of that tool. So you must ensure you're using the same tool for both the male and the female. So we're going to use the 1/4 inch end mill here, and then you can choose the direction, whether that's climb or conventional cutting. We're just going to go with a climb here, and then we can give that a name. So we'll just leave that as male inlay, and then we can simply go ahead there and then press calculate. And then we'll go ahead and preview that toolpath. And so if we just delete our waste material, we can take a look at what we've got here. And so we can see here we have radius externals and we have radius internal corners as well. And so the software is automatically rounding off these internal corners based on our tool geometry. Okay, so let's just put that in Z, and then we'll just reset that preview, and we're just going to close out here. So now we're going to create the female counterpart. So we're going to take the E on the right hand side, we're going to go into the Inlay Toolpath. This time we're going to create a female inlay. We're just going to go with a pocket for this example. So we'll click on the pocket there. Start depth, we're going to put that at 0. Cut depth, we're just going to cut down half of the thickness of our material. So we're just going to go down 1/4 inch. We must ensure that we use the same tool that we use for the male part. So we're going to ensure that that matches up, and it does. We've got the 1/4 inch end mill in there. You can see that. We can do that in an offset strategy. Then we can just give that a name. We'll just call that one pocket inlay, and then go ahead and press calculate, and then we can preview this toolpath here. We can see how it's cut that out. So if we can now go ahead and preview all of our toolpaths, and then for the pocket inlay, we'll just give that toolpath a colour just to make it a little bit more visible as to what's going on over here. And so by looking at our preview, and if we go into the 2D view and just switch on the visibility of our toolpaths, with this solid preview, we can really see that we now have a matching of the rounded corners, where the one can successfully slot into the other. And that's been done automatically by choosing that Auto Inlay Toolpath option. Now we must take into consideration the practicality of cutting inlays, and that's the fit of the male being inserted into the female pocket. And we do need there to have a very small difference in sizes in order for one to fit comfortably into another. As if we cut them both out to the exact size that we have here, then we're going to find it very difficult to slot the parts together. And so the way that we can overcome this is to apply an allowance to the toolpath, where we slightly undersize the male part or we slightly overcut the female part. And that will give us a little difference between the two to allow one to slot into the other comfortably. Now the allowance can be applied to the male, the female, or both, but typically the best method would be to cut the male first and then use that to test to fit into the female pocket, and you can then overcut the pocket until you get the required fit. So let's just double click to go back into the pocket inlay. So in terms of applying an overcut, we can make use of the pocket allowance here, and we can put a value in and the software will overcut by the value that we enter in this field here. So we're going to go with 0.02. Now this value will vary depending on your material, the accuracy of your machine, the size of the tool, and the finish that you may be applying. So we're going to oversize this by 0.02, but for you, you're really going to need to do your own test cuts to ensure that you get the sweet spot allowance to get that nice snug fit. So we're going to go 0.02 in here. And then if we just zoom in over into the 2D view, so currently we can see that our toolpath is filling inside of that vector up to the line of the vector. Now if I press Control and calculate, what that will do is it will automatically update the toolpath preview for us without actually opening up the toolpath preview form. And so if I press Control and calculate here, you can see what it's done there, and we can see the preview of the solid view here within our 2D view. And you can see now that that tool is actually overcutting that vector by the amount that we specified here. And again, it's just important to remember that you need to put in an allowance based on your own test cuts. Okay then, so we can close out of here and then we can just simply go in and then just preview that overcut, so you've seen it just ever so slightly machine that away. And then once you go over to your machine, it'd be a case of cutting the male part first and then checking that it fits inside of the female part. Now in this example that we've looked at, we've cut both the male and the female parts out in the same sheet. And this really is quite unusual, as you would normally apply this technique to two separate sheets using two pieces of material, where you just need to make sure that you're using the same tool for both the male and the female parts. So let's just go and save this file. So just go to File, Save As, and we're going to call this one Auto Inlay Toolpath. Save that and you can access that from the project folder. So now let's take a look at the other two inlay options. So rather than cut a pocket for the female, we could look at cutting a hole and then apply a step to the male, which is pushed through from the back and locates against the stepped shelf, which is then glued together. And so you'd want to use this option if you wanted to create push-through letters, for example a sign with aluminium facing and acrylic push-through letters that could then be backlit. So let's just close out here, and we're just going to go to File, Close, then we're going to go ahead and we're going to create a brand new file. So here we're going to work with a width of 6 inches, a height of 6 inches, and a material thickness of 1/2 inch, and we could go ahead and press OK. So we're going to look at introducing another sheet as part of our project, as though we were machining this in reality. And so the material that we're going to use for the male would be machined from acrylic, and we're going to make it quite thick so that the letters would protrude through the holes of the female part. And the hole of the female part would be cut out of a thin piece of aluminium, so that when we push the letters from the male part, they'll push all the way through and then they'll stick out from the front. So to organise our sheets, let's go to our Sheets tab here. Okay, so we're just going to right click and we're just going to rename this sheet, and we're going to call this one Acrylic. Okay, so this is going to be our male part, and if we just slide this over so we can see the whole of the XYZ dimensions there, we've got 1/2 inch acrylic, and that's what I'm using. Then we can add in a new sheet, and then in this case we can call this one aluminium, in which case I have the same XY dimensions except the Z value is different. So if we go to the edit option over here, we can just decrease this down to 1/8 of an inch there, and then we could go ahead and press OK. So now we've got our 2 sheets. So now we can see them in the 2D view as well. If we zoom out, so we've got the aluminium and we've got the acrylic, and I can double click to make the different sheet the active sheet, or I could simply just double click on the actual name that we've got within our sheets list. Okay, so if we go into the drawing tab, we're just going to go with that same E. So we're going to draw text. We're just going to type in E like so, close that out. We're just going to press F9 to center that. Then we're going to right click and we're going to copy this to the aluminium sheet. So we're going to do that there, and we can see it's been copied over. Okay, so we've got our vectors ready for our different sheets, and then we can simply come over and switch over to our toolpath commands. So we're going to take the E on the acrylic sheet. So this is going to be the male inlay. We're going to go into the Inlay Toolpath. We're going to look at using the stepped male insert. Okay, so we're going to have a start depth of 0. We're cutting down again all the way through our material. We need to select a tool, so we're going to select that 1/4 inch tool from our tool database. And then next up, we need to specify the step dimensions. So here we're going to have a step depth, and in there we're going to put in a value of 0.375. So that's what we're cutting down to. So we'll be left with a step value of 1/8 of an inch. And then we need to input the step width. So that's how much of the material that we go around the actual letter. And so for this, we could just go with a value of 0.2, and that will just add that as a width around the outside of our existing letter. Okay, and then what we can do is we can come down and we can just simply go ahead and press calculate. Now, as we are machining this in an acrylic colour, let's just change up the material. So we could go into the options here, and then we can specify what we'd like to input there. So let's go with a pale blue plastic. And then what we can do is we can simply go ahead and just preview that toolpath, and we can see what that looks like there. So here is the width of our step, and then this is the depth, so we're left with 1/8 of an inch there, and the idea is that's going to push through into the female part where it just sits flush on the back, and so we'd only see the actual protruding letter going through the letter there, and this just enables us to kind of just fix this to the back of the female. Okay, so if we go ahead and tile our windows, and then we can simply close out of the preview toolpaths form. Okay, so we're going to double click onto our aluminium sheet this time. And here we're going to take that vector, we're going to go into the auto inlay toolpath, whereby we're going to use a female inlay where we're going to create a hole. So here we're going to cut all the way through our material. So we're going to type in Z equals, and it's pulling out what we've set for that particular sheet, and that depth is 1/8 of an inch, and we're going to cut all the way through that material. We need to select a tool, so remember it's very important that you select the same tool for both the male and the female inlays, otherwise this is not going to work. Okay, we could apply a very small offset, so 0.02 in this case, and then again we could go ahead and press calculate. Okay, if we go to our material settings here, we could choose to use more of a like a steel and metal colour in this case to closely match the aluminium colour sheet that I'm actually going to machine into. So we can see that there, and then we can simply go ahead and we can preview that toolpath, and we can just delete away that waste material. And so there is the female part. And so there we have it. And so the idea is, if we just switch between our toolpaths, if we go to the acrylic one here and just preview that toolpath, the idea is that this male part will slot into the cutout that we just created on that aluminium sheet, where it'll be fixed together using the step that we've got around the outside of that letter. And so let's just close out here. Then we'll just go ahead and we'll save our file. So we'll go to File, Save As, and then in the project folder, we're just going to call this one Auto Inlay Toolpaths 2, and you can access that from the project folder. And so the key things to remember when using the inlay tool is to make sure that you're using the same tool for both the male and the female parts, and applying an allowance to the female part to ensure that the two parts fit together without any difficulty. And so that completes this tutorial on how to use the inlay toolpath to effectively cut one part and insert it into another.